based on some algorithms which are executed, and then you know make some action. That should be an output, right? That should be an action. So actuators are devices that can play such kind of actions or perform such kind of actions. The Internet of Things is done in 5 categories basically: industrial Internet of Things, consumer Internet of Things, social Internet of Things, semantic Internet of Things, as well as productization Internet of Things. Industrial Internet of Things is where the sensors are used in industrial environment to improve the process of industrial solutions, right? Like earlier they were using belt conveyors, they were also using steam engines to improve the process of industries, right? For productization, for development of products and so on. But now they have a different setup. They started using sensors. So sensors are used to fetch the information, collect the information, and then process that information, so that the process involved in industries, the time that takes to process something in industries are drastically reduced. And also the next category, if you see, consumer IoT, like any IoT devices that are used for personal, personal assistance and so on. So the devices are basically along with you. Like it can be in textiles, it can be like glasses, right? Or it can be some pens, some devices that are in and around you, that like rings and so on are also. So these are devices mostly personal oriented, and they are collecting or sensing data from such environments. Social Internet of Things, it's devices that are used for sensing from social media sites like Twitter, Facebook, and so on, and then the processing of such data happens. So social Internet of Things is another category. And if the social Internet of Things is tailored to semantics, tailored to a particular person, like for example, politician want to address a mass group, but he wants to get the sensed information from or he wants to get the right text for the next speech right in front of him. So this is like tailored to his own requirement, and of course owl based technologies will be used, and he has to collect them from the community who are listening to his talk. The last one is like productization Internet of Things, where the product development itself is made with the feedback provided or collected from multiple group of designers. So obviously there are so many sensors: light sensor, touch sensor, humidity sensor, temperature sensor, force sensor, water flow sensor, and there are n number of applications we can think of by combining all these sensors and collecting the data, so that the intelligence could be achieved with the help of cloud, fog, edge, computing continuum. Well, how these devices send data, that is the next part, right? How the data is sent to either cloud or fog or edge. Let us forget about the three different computing continuum, but let us think about devices that wants to get the data. So at application level, at a higher level, there are some protocols which basically does this. So in Internet of Things world, MQTT is considered to be most popularly used protocol, which is which is able to collect information from sensed data or sensor based objects or tiny objects, right? MQTT is like message queue telemetry transport system, where the messages are transferred in a publish subscribe model. This means the sensors are typically very lightweight, and they are battery operated. most often they are battery operated, and therefore energy is very, very we need to carefully handle that, right? So it is not expected that the sensor should always be live. I mean, it should not always be powered on. Your cloud services are also a little expensive, right? Uh, Instead of, if you have dedicated servers, the infrastructure cost is high. So it is not good to have your own dedicated devices. Instead, we go to cloud services, which is going to now collect the sensed data. So even in cloud, the data is, the service has to be launched in some EC2 instances, or if it is AWS, and then therefore you have to pay for EC2 instances. And these EC2 instances are also not no very cheap, right? So I mean, it's relatively cheaper than our dedicated servers, but you cannot always keep the devices on. So what we can expect in such environments is sensors are not always active. Services that need the data is also not always active, or it doesn't need that. So publish subscribe model is a model where sensors will publish the data, and subscribers like services will go and collect the data whenever it requires that. So MQTT follows a brokering approach where brokers will be in between, and this broker will have to stay all the time live. But all different sensors can keep it could go to sleep mode, and even cloud services or any services could not listen to the sensed data all the time. Whenever they are all up, they can go and start fetching the data. Right. So this addressing is basically done using topics, and there are some challenges and with security. Therefore, SMQTT model, the protocol was designed. Also, there are other protocols like QAP. This is like request response model. So it basically relates to the normal TCP/IP standards. And this QAP model, protocol, is just above the session layer and below the application layer of any ISO OS standard or whatever, right? So here it is following request response. So the sensors have to send the request, and the services should get something from based on the request, and the sensors will have to send it through responses. And as we know, this sensor environment is not always active. So there is the problem of reliability in sending messages. Therefore, this particular protocol follows a kind of messaging system where the messages have some inbuilt or inherent reliability measures. So there are certain features that it can cope up with unreliable situations, unreliable networks, and so on, to ensure that the census data are collected to the services. Obviously, co-op cannot be a better approach in sensor-enabled environments, but still, for some kind of applications, especially like video processing based applications where the cameras are involved. So in that cases, co-op will be okay. And also AMQP is another protocol which is more similar to MQTT, but MQTT had a problem of dealing with the brokers, because there were cases where the doors automatically open without the proper authentication given by the user, and these things happen because of unsecure or insecure brokers in MQTT environment. So AMQP provided one routing mechanism in the broker, which enhanced the security features of messaging and so on. So the DDDS is data centric one, which doesn't follow broker approach to handle data. It is also in based on the concept of routing data and so on. So what we can see here is the data from sensor has to be captured and it has to be processed somewhere, and that is no, at higher level we could see some protocols, and at lower level means no, in ISO OSS standard we will always talk about the lower layers which are responsible for no, sharing the signals, right, with modulations and so on. So there are some standards and protocols involved for such kind of applications, because you cannot treat sensor enabled applications as a normal application, right? When you talk about the edge intelligence, it is purely based on no dealing with no sensed information or data that are very near to the sensor objects. So we have to understand the communications that happen or the protocols that are involved to capture the data from the sensor nodes. And you can see, like, there are some list of such protocols and standards, like IEEE 802.15.4 standard is more commonly used standard in such IoT environments. If we will go through some of those um, protocols, just to give a flavor that the census data are carefully handled. So 802.15.4 is PAN-based standard, which is talking about personal devices, connecting personal devices. This is basically short range, and um, uh, uh, basically it provides the people to develop devices based on these standards. And it is following ISM band, that is industrial, scientific, and medical radio band, which is operating in 2.4 gigahertz. This is one of the frequency band that is used for sensors. Then there are, like, the standards classify the devices into two categories: full functional devices as well as reduced functional devices, because you some devices even don't have full capability to handle data. So that's the reason full functional devices are not always used, right? Like, for example, if you take very small devices like temperature sensors, or these sensors cannot even have internet over there, and we could not claim that this is Internet of Things, but it get attached to some microcontrollers where now the internet is there, and then from even those devices, they cannot sometimes provide like routing capabilities, or handling some certain features, and then they are not considered to be a fully functional device according to IEEE 802.15.4. And then there were evolution of some protocols like Zigbee. um, this is basically a protocol that's very popularly used in home automation related systems, where you can have such kind of small device, right? And with this small device you can connect many number of sensors and create mesh network with a very low price. So the idea would be like, you will have um, a kind of lot of sensors connected here, like hundreds of sensors, and then just this XB will be connected, and it can provide you the entire mesh here, and then you can go to the gateway, and then from there on it can be a connection to normal network. So we need to understand how different communication protocols, or how different protocols are able to collect data, right? Because um, um, when you talk about edge devices or sensor-based applications, we will have to know these kind of or we will come across some these kind of protocols. Zigbee is a very crucial protocol which was developed by Zigbee Alliance, but this was developed, to override the normal ISO OSA layer. ISO OSA layer had 7 layers, right? And this protocol did not follow the ISO OSA model. Why? Because it did not have a transport layer to make the sessions properly, and um, why they brought it, because they wanted to minimize the number of layers, so to ensure that sufficient energy is conserved. I mean, the battery utilization is prevented there in any IoT applications. So bringing down the layers, reducing the layers means that some computation is reduced. When some computation is reduced, obviously the battery optimization is high in such devices. So Zigbee protocol had that feature, but it did not support the normal IoT, normal internet, right? Normal internet connectivity. So any Zigbee device cannot directly get connected to the network. You will have to have a kind of gateway which will make the transition that will feed to the normal network. Um, so you can see here all of this remain the same, like since it is following this particular standard IEEE, sorry, IEEE 802.15.4. Therefore, the range as well as data rate and so on are almost same. It is following ISM band 2.4 gigahertz. So it's all these are almost the same. But what we can see here, only difference here is this application support sublayer instead of transport layer. So you don't have transport layer. That is one important thing, and therefore it is not capable to combine or cope up with the normal internet devices or normal internet services directly, right? So but if you see here, this is like no small thin layer which can be associated along with the application layers. Basically the point is almost the same, only like as like transport layer, only to create the proper sessions with the particular sockets. But instead of such kind of sockets, here you have this binding option, and there is a kind of endpoints for the application, and this will provide such kind of endpoints to connect the applications with the network layer of the Zigbee. So what we should understand here is Zigbee protocol is totally different, and totally different compared to normal ISO OSA standards, and therefore it is it cannot be easily used in every environment. That's what we want to understand, right? That's the reason Zigbees are connected to home, and mostly in home automation devices or home automation systems, and then they will have a gateway, and then it becomes like you are connecting to the normal network, and it keeps going on. So overriding this Zigbee, only they brought the concept of 6-low-PAN. 6-low-PAN is having the objective of 6-low-PAN is having the objective of Zigbee with low power, right? Because the reason why Zigbee was introduced was to bring down the power, right? The energy consumption of the application. So they brought like that, but they changed the layers and so on. In 6-low-PAN, which is based on IPv6, follows the normal IP stack, and because it's following normal IP stack, it is it is better, right? But they introduced some low power features by reducing the functionalities in each and every layers that involves such protocols. So that's the reason 6-low-PAN became more popular, right? And it became like a protocol that can support any kind of sensor nodes and access the data without going for a drastic change in protocols like going for Zigbee or something like that. So you can see the layering here, like 6LoWPAN, ISO-OSI, as well as the Zigbee is compared, right? You can notice that the transport layer is not available in Zigbee. Instead, they have that APS, and on contrary, you can see that the 6LoWPAN follows the normal ISO-OSI standard, so therefore you can use any kind of devices developed using 6LoWPAN to the internet, normal internet. So connectivity is more easy here with the 6LoWPAN, and therefore people started to use the 6LoWPAN commonly. And you can also observe here, like you can have such QAP and MQTT for data collections and so on at application level, higher level. And at the bottom level, you will have such kind of lower protocols. Right. So more other protocols that are even popular in IoT setup is although there are so many other, but I am just going to give a very brief about Wi-Fi as well as LoRaWAN. They are also very popular in sensor-based developments. Wi-Fi is very common every time, and we all know that 802.11 series is very popular. It has very high data rate also, and the range is a little far higher also, right, compared to low pan. But low pan or whatever, like like what we have seen with IEEE 802.15.4, which had a range of like 10 to 10 meters, right? Less than 10 meters. So relatively, Wi-Fi is having higher range, but challenge is the power consumption or energy, right? What it uses for transmitting the signals, because of high data rate and its capability. It has to know. It has to be robust, right? So um, Wi-Fi is very popular also in, if you take many camera based applications like human face recognition applications, or face emotion detection applications, related applications, some airport theft detections. All this involves cameras, and therefore Wi-Fi becomes a very good mantra. And there of course, Wi-Fi 5, Wi-Fi 6. Nowadays, we have Wi-Fi 6 protocols, technologies, which means the speed is somewhere nearing to fiber optics, right? Like 10 gigabit per second speed is there. So how it is happening? Because these devices, Wi-Fi access routers, Wi-Fi access points are little capable because of its orthogonal frequency division multiplexing techniques, and it also has beamforming capability. So this means the antennas can directly point to certain end devices to collect the data. Right. So Wi-Fi and also LoRaWAN. LoRaWAN is something very peculiar. From the name, you can understand long range, wide area network. So all other communications, communication protocols were focusing on um, local area network. If you take Wi-Fi, it is like local area network, right? Or Zigbee, you say it is also like some small network, and then it is it requires some connectivity to the normal network, and then it can connect to the cloud or edge systems. Fog systems, right? But here, if you see, it's already wide area network. So this means it is going to cross a long distance. What would be the distance, right? So typically, it is capable of covering around 10 kilometers. 10 kilometer, just imagine, right? 10 kilometer a connectivity between the access point as well as sensor node. So this means you are having a big farm, agriculture farm, 10 kilometers are there, and then you want to spread across all the sensors like humidity, temperature, soil moisture, and so on, and then all this data just comes to you from 10 kilometers, and you start feeding the intelligence. You can perform some intelligence with the small setup at your home or at your town, right? So even though this is theoretical value, right, it can reach a long distance, but when we did an experiment in urban area, it only covered 500 meters, okay, in urban area. So in rural areas, it is claimed like it can provide 10 kilometer long range, provided the line of sight is also very clear between the transmitter as well as the receiver. But the point what we can observe here is it is long range, right? Um, Very long range. So there is a drawback with this LoRaWAN technology. You cannot send camera images or very no it cannot have long data rate, high data rate, right? Or you cannot keep sending a lot of data all the time. So maybe like temperature sensor is placed somewhere like 8 kilometers away. That sensor can send, this is my ID, and the temperature is 36. That's it. So then with this very small data, the transmission is no okay, and data rate is also very small. So you can see here like how the LoRaWAN technology is looking like, and is also sometimes named as low power because it is extremely having very low power. And the concept is with very simple physics, right? That is, if you increase the bandwidth, obviously the coverage will be less. If you reduce the bandwidth, the coverage can be higher. So there comes the LoRaWAN. So you can see here the bandwidth is very low, like you can only send very little data, but it can reach a long distance. Comparatively, Wi-Fi or like mobile networks like 4G or 5G cannot send that much distance, but the bandwidth will be very, very high here, right? So you can see that things networks and some popular players are around for providing such LoRaWAN tools. Yeah, these are like some gateways which are shown in Glasgow in UK. And so what so far we have seen is like we have sensors, we have actuators, and we have some devices, right? Some networked devices, and how sensors are going to collect data, right? At lower level as well as higher level was discussed so far. Now we are going to discuss the networked devices part, that is distributed intelligence part. So basically now people are more focused on edge, right? People are more focused on edge. Therefore, I will be covering this edge part. Before that, let us see that how this intelligence is, really important. So you can see any kind of computer vision applications, learning inferences, or any set of such applications where deep learning can also be involved, right? So deep learning is very simple. It's a subset of AI, and AI is like a very broad topic, and ML is one subset, like a category in AI where you use structured data to use algorithms to learn using machines. But deep learning doesn't use such kind of any kind of structured data, as like how humans just see some data and start to make some intelligence, right? As like that, deep learning also has some layers of or large layers with some algorithmic features like convolutional neural networks, and then with those layers it start to collect as many data as possible It doesn't want to know that this is what the data. It simply can collect all data in any unstructured fashion, and then it tries to get the patterns out of that data or features out of that data. Let it be healthcare, economy, forecasting, personal assistant, or whatever. Deep learning is going to do that as like humans, right? So deep learning is like more computational part which require large large networked devices, like large distributed devices, right? So um, earlier, traditionally, what people were doing, sensors were directly connected to cloud. There were no concept of like edge, fog, and something like that, right? So only cloud. So cloud services will be there. Sensors will send the sensed data to the cloud. Cloud will make some intelligence, and from there, the sensors, the cloud intelligence will say that now you do kind of notification, send an alarm, something like that. Then the actuator will do that, right? So this was a practice earlier. Of course, cloud is a scalable computing. It has large number of computing. It can perform deep learning, machine learning for structured or unstructured data. It can have very scalable environment. Data mobility is possible. Even cost is also relatively less, right? Owning a infrastructure is very expensive than what you have with cloud. So cloud is always good. Cloud in practice is always good for such applications. But nowadays, people started to think about fog as well as edge, right? Why? Why we wanted to have such computing continuum, right? Why sensors should not send data directly to cloud alone? We all know cloud is no third party hosting infrastructure, right? Third party means like Amazon, Google, or some other person is hosting your cloud, your data, right? Which is not so good. And sensors sometimes no need to, or the actuators need to do some action immediately based on some sensors, right? It's like no, you as a human, when you touch a fire, you immediately take your fingers out of that burning sensation, right? uh, Usually what will happen, um, whatever you sense, you see some objects, data goes to the brain, and the brain is processing that. It's something like cloud, right? Every data goes to cloud and it makes the processing, and then some action is happening. But there are requirement where immediately when you touch a fire, right, the data should not go to brain, and then brain should not make the processing, and now it should not say that you just release the hand from the fire. So this should happen very immediately, very nearer to the sensor, right? So this is where the computation is now classified or divided in levels. Okay, so um, among this, no, fog could be like one data center, one small data center in industry's main center, or maybe in a university's one hub, right? Or in maybe in smart city, in one city location, one big data center is available. So they are like no fog level. And edge means no, it is very near to you. So this means no, I am having a pen, it is having a sensor, and this pen is not sending data to cloud or fog immediately. It will make some processing here itself. So that's the advantage. And edge intelligence is therefore very important. It is a distributed computing technology in which information is processing in and is located close to the things. So why? Very important. Some points are like network bandwidth is less, response time is high, security and privacy is also high. Say, think about face recognition application. You want to show your face, and do you expect the face should go to cloud? Your face should go to cloud. Then what would happen is no, there are people to create memes out of that, right? Your face will be taken by someone else from the services if it is data leaked, and then they can create memes, and it will come back to you in different stage, right? Which you cannot really accept, right? So these are all challenges in direct cloud environments, right? So cloud to direct cloud to thing or thing to cloud. This is not a good approach. So edge prevents that, right? So when you talk about edge, when you talk about edge intelligence, learning is categorized in certain levels. Okay, like federated learning, gossip learning, transfer learning. These are some learning features that are adopted. So learning, basically all data are collected using different protocols, right? As I told, communication level protocols as well as higher level protocols, data are captured, and these data uh, comes to edge device. What is edge device? What are the different types of edge devices? Some examples would be like Jetson Nano, Raspberry Pi, some small microcontrollers. Some people don't categorize microcontrollers as edge devices, but still some researchers claim that it is making some sort of processing, therefore it could also be a edge device. Coral Dave and so on. So these are some devices that can be very near to your sensed node, even your mobile phone, right? It can also be like a edge. Some fanless laptops or fanless Intel processors can also be like a edge devices. There are a few accelerators, even Intel Movides, neural sticks. These are all some accelerators that are also used for increasing the speed of sensed data. Thousands of sensed data come, and the edge device will make the processing, and then the processed data will be sent to the next level, and then goes to the next level of cloud for higher processing. So federated learning is like a collaborative learning environment, which is like master worker approach. It has some algorithmic approach where the master will aggregate the model without knowing the local data. So what is this learning in very simple form? We all know, when we are introduced, our brain also has to learn, right? How do we categorize that this is a pen, right? It is based on so many attributes, right? Many people keep teaching us this is pen, next one is this is pen, this is pen, and then no, it is the human brain start to collect the attributes that are more uh, or the features that are no more relevant to it, like pen means the size should be this much, the color should be this much, the color should be like this, and so on. And then it keep comparing, and finally it comes to a state where it tries to frame a kind of mathematical model, and then this model is refined with some validation data set, and then once your model is perfect, or your equation is entirely perfect, then it can go to the test environment, as like human beings walk, right? It is also like a lot of learning there, right? So baby makes some steps, then it start to walk. Even you also, when you walk in a mountain, or some trekking places, different unknown environments, you keep always try to formulate the equation, right, in the brain, and that mathematical equation is um, collectively made, and then you try to uh, test it with some real test environments. When you go to some real hiking environment, you change the mathematical model so that you will understand that you have to take the foot, you have to take the steps like this. If not, you will fall down. If not, you will you will have to slip, right? So all these are like mathematical models where the learning is happening. So algorithm is written to create such equations, and federated learning is an environment where the equation is now created in a combination of not only cloud but also edge devices, right? So there will be a master and some set of aggregates, or I mean slaves, or clients. So master will try to create the model aggregatively with the data that are available from the edge, different edge nodes, and then it will create the bigger collective model. Gossip learning is an approach where here again, edge, fog, cloud can be used, but it is like an algorithm itself is split into multiple distributed computing. um, so for example, you can use like MPI programming or OpenMP. OpenMP is not fitting well, right? Distributed compute programming models like MPI could be used, so that some computations are certain computations are distributed across multiple nodes, and few nodes can be from fog, few nodes can be from edge, few nodes can be from cloud, and you can make the learning process. So there are so many advantages, disadvantages of different such learning environments. Transfer learning is where you try to learn or create the model from the model that was already given to you, or maybe you have created a model for some environment, but with that environment model you create another model with the local data set in the edge, right? So maybe um, you have a model for classifying flower, right? That model can be transferred to edge, where you wanted to classify some other category of flowers, right? So the model is transferred to your place, and then you with your local data set, without sending your data to the cloud, you are making the learning or updating the models at the edge itself. So this is another category of learning intelligence. In fact, the performance is very important one. People have followed several methods like caching, compressing the model, splitting the DNN, right? The splitting the layers, placing services in different locations, offloading the edge computations to certain places, training and inferencing in a different distributed location. So these are some techniques people have followed to improve the edge intelligence. Now, where comes serverless? Serverless is a execution model. Okay, execution model in cloud. We told that no sensors, right? All the sensors can connect to edge. So there is a small processing in the edge level, and then you can use fog, one data cluster or data one clustered unit, and then you can have a very robust cloud with lots of scalable computing and so on. And we told that there are some learning mechanism where you can use algorithms to distribute the load to cloud, fog, as well as edge. Why we need edge? We need edge, or the learning has to be sometimes done in edge, because you need to have very low bandwidth, network bandwidth for your entire application, like social good applications, right? And you also sometimes you need to have a very good privacy of the data. So therefore also you may need this edge. We told like that. But where comes serverless? Serverless is a execution environment, right? What is this execution environment means? Usually the sensor data are processed in edge, fog, or cloud in a way that the services are always enabled and kept enabled in a computing machine. So if you take this IoT cloud application or social good application, if you involve five compute nodes in edge, if you use one data center in fog, and if you use 10 EC2 instances, 10 EC2 instances in cloud for one application, totally you are using totally you are using something around like 16 machines, okay, for your application. If you don't use serverless, what would happen is all these devices will be powered on. Okay, all are powered on, and all you will have to pay. Especially edge means you are having your own device usually. Therefore, you are not no. It is like one-time investment. But fog as well as cloud, you will have to pay usually. right? Fog also, if you think like governmental organization, then you have a smart city and you have a cluster in the smart city, then you are not going to pay. But cloud, you are always paying, right? You have to pay. So 10 EC2 instances will charge you some amount, and that will be always there, and you have to pay that. You have to this is initial investment you can avoid, but here you have to make the payment. Also think about the energy. You if you always keep the machine powered on, it is like, no, you are consuming a lot of energy here, you are consuming a lot of energy here, you are also consuming a lot of energy here. If energy is consumed, what will happen? Carbon monoxide emissions are there, and then people talk about like carbon dioxide emission, carbon monoxide emissions, and so on, which is harmful to the green environment. So obviously, what we can see here is, if you don't use serverless, all devices are powered on for your application, right? In serverless, it is a execution environment in which you don't keep the machines powered on. So whenever the data is sent, it will become like a event, and this event will trigger a function, and this function will ensure that the devices are enabled, right? So this means the server is powered on only when some sort of event is triggered. So this means the server is not always on. So serverless IoT architecture is very crucial, and you can apply this for any level, even in edge level or fog level or cloud level, thinking of different performance metrics like energy or carbon emissions and so on. And therefore serverless environments are very good. And so far I was saying, like, AWS was providing AWS IoT, and they were also providing a edge platform which was named as Greengrass, right? I was saying that Greengrass is used. They have also provided additionally serverless environments through Lambda functions, as well as Google has also provided some serverless environments, and all the other cloud providers have also developed their own serverless environments. So serverless environments are a kind of execution environment. There are also performance issues here, and this is listed here in this article. I don't know how much time is left out. Maybe I can take another 5 more minutes. So, yeah, performance concerns are also there with these serverless environments. Like, for example, depending on whether the devices are always powered on or it is not, it's powered on, but it is idle. We classify it as cold or warm start. And because of security concerns, because of non-availability of resources, because of some mapping issues, there are so many performance issues for such serverless environments. You can monitor them, and there are a few monitoring approaches, basically, like if you monitor them based on the traces, right? Like based on the logs. If you have a software that will go through the logs, and if it capture the issues behind the serverless functions that are executed, how the trigger has failed, and whether the trigger is working or not, and so on. So that is like tracing approach. Sandboxing approaches are there, where you create a separate, isolated environment to test whether the serverless functions will work perfectly. Or modeling, as well as the prediction approach, as well as language inherent approach, where you feed some additional functions and then you collect the performance values of those serverless functions. These are some of the tools that are already available and developed by different providers to detect performance, right? Like Amazon has X-ray, Prometheus is developed, Google has a Stackdriver, CloudWatch, AppDynamics, Wavefront, Epsagon, and so on. And a few have developed for commercial purposes, and a few have been developed as a tracing model. Some have implemented that as library, some has implemented as services. Some are capable to measure functions. Some are even capable to measure not only functions but also task as well as application level. So what research directions are there in this particular field is the tools whatever you develop sometimes are also bound to proprietary, right? And therefore you might not properly get the correct performance value of serverless applications. Basically you can apply edge intelligence, right? So far what we have seen, no, we started with uh, like IoT, right? Because if you take any social good application, sensors are required, right? Sensors actuators are like two important pillars that one collects the data, one perform action based on the data, and once after you collect the data, you want to do some intelligence, you have to perform some intelligence. This intelligence can be directly done in cloud, but what what is the important topic of discussion for this particular FTP is that we don't send directly the data to cloud. We should have some data processed at the edge level itself, right? And then you make the processing in fog and then to cloud. That is the best computing continuum, right? And edge intelligence, there are certain techniques, and there are some performance issues in such environments, like when you talk about federated or so on. And we also have seen how to collect data, like there are certain protocols that are used to collect at the communication handle the devices whatever you manufacture in communication level as well as the application level, right? And we have seen how these data should be processed, or the intelligence should be carried out at edge level, like federated learning, gossip learning, and transfer learning, and so on. And we have then discussed about serverless way of executing applications, where we told that instead of keeping the server instances always on, we can always keep the servers off, and based on the data triggered from sensors, now edge will search for one compute instance, or now the fog will search for one compute instance, or cloud will now search for another compute instance. Based on that, the servers are started, and then the server instances or compute instance, let us say compute instance, and the compute instance will start to do the action or perform some action based on the algorithms whatever you have. And there are so many challenges when you perform such serverless implementation. So there are n number of research works that you can think of when you apply edge intelligence as well as serverless environments. Also, mapping them is also another challenge which you can basically see here, right? Finally, yeah, you can go through some of the publications. And before I end, let me also share you some of the important activities here at our incubation center. We are having two incubation centers. One is MSME Incubation Center as well as Atal Incubation Center, where Atal Incubation Center is, it is serving as a Section 8 company. We can support novel ideas to the tune of 50 lakhs per startup. And there are also provisions where the startups can startup could even be like a student startup, which means student has developed their product and they have their company functioning, or it can be a institute level startup which will be hosted from the institute as a company, and they have a product and they wanted to get supports. So I'm always open to have such developments jointly. And with that, let me thank the organizers once again, Professor Arunachalam as well as Professor Shushila Madam for inviting me, as well as the principal of SKCET. Thank you so much. and have a nice time ahead for the next few days of your FDP.
Good. Thank you so much, sir. Thank you so much for taking the time to present your thoughts among the participants. So thank you so much, sir. So participants' feedback link will be shared through the WhatsApp group. You can fill the feedback form for day one. So attendance will be tracked from the Microsoft team itself. Okay. Thank you.